are going to continue the projectiles, the third part, that is, we are going to check for the numericals on for projectiles on inclined surface. So in the previous video, what we learned, they were the projectiles which were on the horizontal surface. Now we will see a few problems that we will be solving on inclined surface and the equations related to that. So projection on inclined plane, how that would look like? It would be like this. So previously your plane used to be like this. Now the ground is inclined, as you can see, with an angle of beta here. So this is the original ground, OA, what you see. So from here, O, the projectile is thrown with an velocity, initial velocity of U, and starts from O, and this will be the trajectory and reaches at V. Okay, so this inclined distance, what you see, OB, is the range, and this projectile is thrown at an angle of alpha with respect to horizontal, and this plane ground is inclined with an angle of beta. We'll see one by one what it is there. I mean, the definitions here. So let OA be a plane inclined at an angle beta with horizontal. Consider a projectile from the origin O on an upward inclination surface OA. Let the projectile strike the inclined surface at B as shown in the figure. Let U is equal to initial velocity of projection. Alpha is equal to angle of projection. Since this inclined surface, what you see, it's projected upwards, up this x-axis. So that is positive. If it was down the, alpha or beta, whatever it is, if it is projected downwards, usually beta will be projected downwards, in that time it will be negative. And beta is the angle of inclination. So this is angle of projection and this is angle of inclination of plane OA with respect to horizontal. So this may be, you can see the ground like this climbing up, or sometimes it will be coming down like this. So that time the difference will be this, in the first case it will be plus beta, and the next case it will be minus beta, negative side. And t will be the time of flight, where the projectile will take the time to travel from O to and then to reach B. R is the range of inclined plane. So whatever this distance OB you're seeing, no, that is the range in this inclined plane. Then D is equal to horizontal distance OC. So whatever this D you're seeing, that is nothing but the horizontal distance from O to B. So OB directly, whatever it is the inclined distance R. If you want to find the horizontal distance between O and B, that will be this OC. Which as if you want the vertical distance between O and B, that will be this BC. Okay. So for this, we will get to know the equations. So to find the range R, previously for an horizontal surface, we had a different equation. For this, we are going to have another equation, which we just need to remember the final equation. So to find this range R, so here range, whatever what it is, OB, not in this direction we have. Now we have an inclined range like this. So how do we find that? So substituting x is equal to OC and y is equal to BC. As you see here, since the projectile is going to trace the path of a parabolic path, we know the equation for the path of the projectile, that is y is equal to x tan alpha minus gx square divided by 2u square cos square alpha. So we are going to substitute the values of x and y for this range. So the x value, that's the horizontal distance for this range, will be this d, that is nothing but, we know this range and this angle. So r cos beta will be the horizontal component and r sin beta will be the vertical component. So we are going to substitute the horizontal and vertical component here, and then we are going to simplify further to find r. So we have directly written it. R, we will finally get it as 2u square cos alpha divided by g cos square beta into sine of alpha minus beta. Okay, so this is the final equation for the range in an inclined plane, where alpha is the angle of projection and beta is the angle of inclined plane. Okay, then to find the time of flight. Once we are done with range, we need to find the time of flight. We know distance, velocity and time, how it is related, right? So horizontal distance is equal to velocity into time. So horizontal distance traveled, that is OC, is equal to horizontal velocity, that is u is the velocity, but its horizontal component will be u cos alpha into time. So making use of this, we can find the equation for time. You will get it as time of flight t is equal to 2u by g into sine of alpha minus beta divided by cos beta. You need to remember this also. Remember this equation for r as well as time of flight t. Okay. Then it's a note, what I said in the previous slide. If this angle of this inclined plane beta is upwards like this, you will take it as positive. If it comes down, it will be negative. What you usually take it. So what will be the difference in the equation here in R and T? It's just that wherever you find beta, you're going to substitute, instead of beta, you're going to substitute it as minus beta. That's it. Only that difference will be there. So we can see the problems for that also. We have two simple problems. One is for a positive beta and another one for a negative beta. Okay. So the first one, a projectile is projected with a velocity of 250 meter per second at an angle of 60 degree with the horizontal from the foot of a plane, having inclination of 30 degree. Okay, the plane is having an inclination of 30 degree. Determine the distance where the projectile will strike the plane, that is nothing but the range. Okay, and the time of flight taken. Take g is equal to 9.81 meter per second square. The question is very clear. You know the equations. Just take the values of, the equation of range, equation of time of flight. Just substitute these values. But be very careful with the beta. Uh, to start with, we need to start with the figure for that also. First, we will write down the given values. So velocity of projection they have given, that is u is equal to 250 meter per second. And angle of projection alpha is given as 60 degree with respect to the horizontal. And angle of inclination of plane with respect to horizontal is given, that is beta is equal to 30 degree. Okay, the figure would look like this. Okay, so beta is positive here, therefore it is positive, and alpha is equal to 60 degree, u is this much. You need to find out this OB, that is nothing but the range and the time traveled by this. Okay, so we have the equations. Distance where the projectile will strike the plane, that is nothing but the range. You know the equation already for an inclined surface, r is equal to 2u square cos alpha divided by g cos square beta into sine of alpha minus beta. You know the value of u, you know the value of alpha, you know the value of beta, g also you know. So why don't you substituting the corresponding values. Simplify further, you get the answer as range is equal to 4,247.37 meters. So this will be the value for range. Okay. Then if you want to find the time of flight, you know the equation t is equal to 2u by g into sine of alpha minus beta divided by cos beta. Okay. So substitute all the values of u, alpha, beta and g. This is substitution, and you get t is equal to 29.427 seconds. So whatever they have asked, we have found out. So range is found out and the time of flight is also found out. Remember that range is nothing but from O to B. They did not ask anything horizontal and vertical. You have directly found out O to B. Okay. So we are done with this problem. Next problem, we will see what it is. A stone is projected from O, located on slope with a velocity of 3 meter per second at an angle of 25 degree with the horizontal as shown in the figure. Determine the coordinates of the point B, its coordinates of the point B at which it will hit the slope whose inclination is 25 degree to the horizontal. So the figure is given for this data. You can see here. So they have given in the figure, it's a downward inclined slope. They have mentioned u, initial velocity will be u is equal to 3 meter per second, and it will be thrown at an angle of alpha is equal to 25 degree. Then You need to find out the coordinates for this point B. You can see this end point of this projectile now B. You need to find the coordinates. Coordinates means you need to find out X and Y for this point. Okay, be very specific. It's for this point. Okay, at which it will hit the slope whose inclination is 25 degree to the horizontal, which is as shown in the figure. It is 25 degree. Obviously, it can't be in the same line. That's why it is downwards. So this is the figure here. Remember that beta is equal to minus 25 degree. So the only change in the equations will be wherever you find beta, you need to substitute minus beta. Instead of beta, substitute as minus beta. Okay. Given values, u is given as 3 meter per second, alpha is given as 25 degree, beta is given as minus 25 degree. Okay. So range of flight we will start with. So range is equal to 2u square cos alpha divided by g cos square beta divided by sine of alpha minus beta. So substitute very carefully. If you can see here, beta is substituted as minus 25. Here beta will be minus of minus, so it will be plus 25. So solve and you will get the range as 1.55 meter. Okay. So this is the range we got. But we need to find out the coordinates for that point B at the end point. Okay. So I'll decide that let x comma y be the coordinates of point B. So OBC is a right angle triangle in the previous figure. OBC. Okay. Uh, if you want to see back. So see it here. OBC is a right angle triangle. We have just drawn a perpendicular. So this is a right angle triangle. We know this angle and we know this range. So obviously you can find out X and Y for this. Obviously, if you see the coordinates here, this is X will be positive and Y will be negative because we are measuring down the X axis here. So X will be positive and Y will be negative. Remember this and we'll move further. So these are the values given and we solved R, and X and Y we have decided the coordinates. OBC is a right angle triangle. From there we can write tan beta is equal to Y by X. Okay, we know that. So tan beta here is tan 25 degree. You're just taking the triangle and concentrating on that. So tan beta is tan 25 degree is equal to Y by X. So y is equal to 0.466x. Okay, so this is equation number 1. We will set it as. Also, we know that r square is equal to x square plus y square. So why don't you substitute r, that is the range 1.55 square. Y in terms of x we can substitute it here 466 x square, x whole square. And if you do that, you will get a quadratic equation, and you can find out x is equal to 1.405 meter. You got the value of y. You can substitute back and find out. Sorry, you got the value of x 1.405 meter. Substitute back in equation number 1. You get it as y is equal to 0.654 meter. So this would be the coordinates x comma y. But you should take care of the directions. Here we didn't consider the direction, but we know from the figure what would be the direction of x and y. So we can conclude, therefore the coordinates of the base, that is B is 1.405 meter and 0.654 meter. Please take this as minus since we are concentrating on coordinates. It will be on the negative side. Okay, it's not mentioned here, but take it as minus. So these are the references made. Thank you. So here projectile portion will be completed.